Audio Jungle.
Welcome to chemistry classes. In this video we have to discuss here stoichiometry. IGCSE chemistry lesson stoichiometry. Okay, so here we have to discuss here name and formula of the compounds. Name and formula of the compounds. First we have to discuss here name of the compounds. Name of the compounds. There are many compounds with two elements. Compounds with two elements are called binary compounds. Binary compounds. Elements with two compounds with two elements. See here, these are the different compounds which contain two different elements. This type of compounds are called binary compounds. Binary compounds. Okay, so here we have to discuss here compounds which contain one metal and non-metal. Compounds which contain metal and non-metal. Name of metal we had to mention first. Okay, we had to mention name of the metal first. Okay, and name of non-metal end with IDE. Name of the non-metals end with IDE. See here, these are the example for compounds which contain metal and non-metal. Sodium chloride, magnesium chloride, potassium bromide. So if there is any compound with metal and non-metal, we have to mention the name of metal first. See here, sodium chloride, magnesium chloride, potassium bromide. We have to say the name of metal first. And here chlorine, non-metal chlorine. Okay, so we have to say chloride. Okay, instead of chlorine we will say chloride. Okay, the name of non-metal end with IDE, chloride. Bromide. Okay, here sodium chloride, here magnesium chloride, here potassium bromide. Potassium bromide. So here we discuss binary compounds. Binary compounds mean compounds which contain two different type of metals. Two different type of elements. Okay. Then we discuss compounds which contain one metal and non-metal. We had to mention the name of metal first and name of non-metal end with IDE. Example sodium chloride, magnesium chloride, potassium bromide, etc. Clear? Okay, so we discuss here compounds with metal and non-metal. Next one we have to discuss here compounds which contain both non-metals. Compounds, binary compounds which contain non-metals or compounds which contain non-metals only. See here, example here, HCl, HBr, H2CO3. So the compounds which contain non-metals with hydrogen. So we had to mention the name of hydrogen first. Okay, non-metals which contain hydrogen. Hydrogen, we know hydrogen, it is non-metal. Okay, so compounds which contain non-metals only. Also it contains hydrogen. So we had to mention name of hydrogen first. See here example hydrogen chloride, hydrogen bromide, hydrogen carbonate. So we had to say name of hydrogen first. Okay, and second element it's end with IDE, hydrogen chloride. Second non-metal its name end with IDE, hydrogen carbonate. Except this one, okay, CO3 it will be carbonate. Okay, and here hydrogen bromide, hydrogen chloride, etc. Okay, next one we have to discuss here the compounds which contain non-metals only and there is no hydrogen. So how to mention its name? See here example, here carbon and oxygen. These are the compounds which contain non-metals only, carbon and oxygen, oxygen and fluorine. So here we have to mention the name of the non-metals with the lower group. In periodic table we know there is group and period. Okay, so this is non-metals only, carbon and oxygen. Okay, this is the compound, and here non-metals only, and here we know carbon, it is group 4 in periodic table, carbon in group 4 and oxygen in group 6. Okay, so which one is lower group, less group? This is lower group, so we have to mention the name of carbon first. Okay, here carbon dioxide, name of this compound carbon dioxide. Okay, so here we have to mention the name of the non-metal with the lower group first, carbon. Okay, and here 2 oxygen, carbon, oxygen 2, that's why we had to say carbon dioxide. And here second non-metals, its name and with the IDE. Okay, carbon dioxide. Clear? Next one, see here another binary compound which contain oxygen and fluorine. Oxygen group 6, fluorine group 7. Okay, fluorine group 7. So which one is lower group? Oxygen, lower group. So we have to mention the name of oxygen first. Oxygen difluoride. Oxygen difluoride. Oxygen difluoride because 2 fluorine. Okay, also name of fluorine and with the IDE. So here we discuss compounds which contain non-metals only. So compounds with non-metals also it contain hydrogen. So we had to mention name of hydrogen first. Next one, here compounds which contain non-metals without hydrogen. So we had to mention the name of non-metal with the lower group first, and second element, second non-metal name and with IDE. These are the example. Okay, next one we have to discuss here making formula from the structure of compound. Okay, we know every compounds they have definite formula. And this formula of the compounds which contain different symbols of the elements and different numbers. Okay, formula of the compounds which contain symbols of the elements and different numbers. Clear? So let us discuss here how to make formula from the structure of the compound. First one, sodium chloride. We know sodium chloride, it has giant ionic structure. We learned already structure of sodium chloride. Structure of sodium chloride means we discussed ionic compounds. We discussed macromolecules. Macromolecules example silicon oxide, graphite, diamond. We discussed already. So here sodium chloride, it is giant ionic structure. It is ionic compound, giant ionic structure. Okay, and here sodium chloride, giant ionic structure, it is made up of positively charged sodium. It made up of Na plus and Cl minus. Okay, giant ionic structure, so it made up of Na plus and Cl minus. Therefore the formula of sodium chloride is NaCl. Sodium chloride, it is giant ionic structure. It made up of Na plus and Cl minus. That's why the formula of sodium chloride is NaCl. Clear? Next one here, water. Water, it is molecule. Water, it is molecule, and one molecule of water which contain 2 hydrogen and 1 oxygen. 2 hydrogen making covalent bond with oxygen. Okay, 2 hydrogen and 1 oxygen making covalent bond. It is molecule. Okay, molecular structure. That's why the formula of water molecule is H2O. This is the formula for water molecule. Water, it is molecular structure and it contains 2 hydrogen and 1 oxygen. They making covalent bond. So the molecular structure, water molecule has molecular structure with 2 hydrogen and oxygen. So its that's why the formula of water is H2O. Formula of water H2O. Okay, next example we have to discuss here silicon oxide. We know silicon oxide, it is macromolecule. It has giant covalent structure. Also we know one silicon atom making covalent bond with 4 different oxygen atom. One silicon making 4 covalent bond with adjacent oxygen atom. Similarly, one oxygen making 2 covalent bond with adjacent 2 silicon atom. One silicon joining with 4 oxygen. One oxygen joining with 2 silicon. Look here, this silicon making 4 bond. 1, 2, 3. 1, 2, 3, 4. Similarly here, this oxygen making 2 bond. 1, 2. Okay, so the ratio of silicon and oxygen is 1:2. 1:2. Okay, that's why the formula of silicon oxide is SiO2. 1:2 ratio. Okay, so the formula of silicon dioxide SiO2. So according to the formula, according to the structure of the compound, we can make the formula. So here we discuss sodium chloride which contain Na plus and Cl minus. So the formula is NaCl. And here water covalent bond molecular structure. Here molecule which contain 2 hydrogen and 1 oxygen. So it is H2O. Silicon dioxide, it is macromolecule, giant covalent structure, 3-dimensional, unlimited structure. Okay, ratio of silicon and oxygen is 1:2. Okay, so the formula is SiO2. Clear? Okay, so we discuss how to make formula from different structure. Okay, we discuss how to make formula of the compounds from different structure. See here, in giant molecular structure or giant structure of the compounds like sodium chloride, silicon oxide, they have giant ionic structure, giant covalent structure. This type of giant structure do not give information about exact number of atoms. Giant structure means 3-dimensional network structure. Okay, so we cannot predict one molecule. Okay, so there are different type of atoms. There are different number of atoms bonded together form 3-dimensional unlimited structure. And this type of structure giving information about ratio of different atoms. Not giving exact number of atoms in a molecule, it giving ratio of the different atoms in a molecule. Okay, see here example sodium chloride. We know sodium chloride it made up of Na plus and Cl minus. Sodium chloride it made up of Na plus, 1 Na plus and 1 Cl minus. Okay, but it is not one molecule. One molecule of sodium chloride. We cannot say one molecule because it is giant structure. Giant structure means it contains many Na plus, many Cl minus. Okay, there are many number of Na plus and Cl minus in giant structure. It is not one molecule. Okay, so the ratio of sodium and chlorine is 1:1. So this is the ratio of different ions in a compound. Na plus and Cl minus, it is 1:1. Similarly here silicon oxide. We know silicon oxide, one silicon bonded to 4 different oxygen atom. This oxygen again making bond with another silicon. Okay, so here the ratio of silicon and oxygen not 1:4, not 1:4. The formula we have to, the ratio of these ions are like this. Silicon its valency 4, oxygen valency 2. Okay, so here it will be 4 and here it is 2. 2:4. 2 and 4 we can simplify with a common number. So here silicon it will be 1, oxygen it will be 2. So the ratio of silicon and oxygen is 1:2. So the formula of silicon oxide is SiO2. Okay, the formula of silicon oxide SiO2 means here the ratio of silicon and oxygen is 1:2. 1:2. This is the ratio of silicon and oxygen. Okay, so here simply we can say giant structure of the compound, it giving information about the ratio of different atoms. The ratio of different atoms or ratio of different ions in a compound, and it do not give information about exact number of atoms in a molecule. Clear? Here next one, see here molecular compound. So these are giant structure. Next one molecular compound. Molecular compound example water we discussed before. Molecular compound example water molecule. In water 2 hydrogen and 1 oxygen bonded together. So the molecular formula of water is H2O. In water hydrogen 1 oxygen making bond with 2 different hydrogen. So it is H2O. So in molecular compound it giving exact number of atoms in a molecule. This is molecular compound. H2O it is molecular compound. So one molecule of compound which contain 2 hydrogen and 1 oxygen. Okay, these are giant structure. These are 3-dimensional network structure. So we cannot predict one molecule contain this much number of atoms and exact number of atoms we cannot predict over here, but in molecules we can predict, we can fix it. Okay, example here water which contain 2 hydrogen and 1 oxygen, and here we can say only ratio. From the formula of giant structure we can predict only ratio of different atoms and ions. Next one we have to discuss here valency. Valency means combining power of an element. Combining power of an element called valency, or we can say valency means number of electrons lose, gain or share by an atom to make bond. To make bond, to make new bond, one atom lose or gain or share how many electrons? This number of electrons are called valency. For example, you know hydrogen. Hydrogen share 1 electron to make covalent bond. So valency of hydrogen 1. And for sodium, you know sodium outer shell 1 electron. Sodium it is metal. It lose 1 electron to make bond. So the valency of sodium is 1. Okay. So here lose, gain or share. So hydrogen share 1 electron. So valency 1. Sodium lose 1 electrons. Valency 1. What about chlorine? Chlorine atomic number 17287. And chlorine it is non-metal. It receive. It gain 1 electron. So number of electrons gain 1. So valency 1. So all this case valency 1. So simply how can you find valency from periodic table? You can check this is periodic table. In periodic table you can see group and period. So using this group you can predict the valency. Okay. So see here group 1 to 4 in periodic table, group 1 to 4 their valency same. Okay, group 1 to 4 their valency same, their group number. Okay, for example, you know in first group you can see hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. All these are group 1, they have valency 1. And group 2, beryllium, magnesium, calcium, strontium, barium, radium. These are group 2 elements and their valency 2. Okay, and you can see group 3. Group 3, boron, aluminium, gallium, indium, thallium. So their valency 3. Okay, carbon, silicon, germanium, tin, lead. Group 4, their valency 4. So group 1 to group 4, their valency same their group number. Okay, group 1, their valency 1. Valency 1 means the charge of hydrogen 1, charge of sodium 1. Okay, lithium plus 1. Similarly, potassium plus 1, rubidium plus 1. So valency 1 means they are monovalent and they have plus 1 charge. Group 2, their valency 2 means all group 2 elements they have plus 2 charge. Okay, so here beryllium, magnesium plus 2, beryllium plus 2, calcium plus 2. Okay, so you can find their charge also from valency. Clear? So 1 to 4, their valency same. What about group 5 to group 8? In periodic table, group 5 to group 8, you can find its valency using this equation, 8 minus n. 8 minus n. Here n mean number of valence electrons. Valence electrons mean number of outer shell electrons. Outer shell electrons. Okay. So see here, nitrogen 8 minus 5. Number of outer shell electrons, or you can say, or you can use group number. For example, look here, you want to find the valency of nitrogen. So this is the equation, 8 minus n. So 8 minus n. Nitrogen which group? You can check periodic table. Nitrogen which group? Group 5. So 8 minus 5. So nitrogen, valency of nitrogen, it is valency of nitrogen is 3. Okay, and phosphorus, you want to find the valency of phosphorus. So 8 minus 5. Okay, phosphorus also group 5. So 8 minus 5, it is group valency 3. Here oxygen, it is group 6, 8 minus 6, valency 2. Argon, you know, here in periodic table, last group, helium, neon, argon, krypton, xenon and radon. These are noble gases. These are last group 8 elements. Okay, they are group 8. So you want to find the valency of argon. So 8 minus 8. Here group number 8 minus 8. So here all these elements they have valency 0. Here helium, it is group 8. So its valency is 0. You understand? So accordingly you can find its valency. So here I told you, using valency you can find its charge. These are metals. All metals they have positive charge except hydrogen. Hydrogen, it is non-metal. Its valency 1, it is plus 1 charge. Except hydrogen, all other non-metals they have their charge minus charge. For example, here nitrogen minus 3, phosphorus minus 3, oxygen minus 2. Okay, and here these elements they have valency 0. There is no charge. Okay, next one we have to discuss here, making formula from valency. How to make formula from valency? Let us see here different example. First one, hydrogen sulfide. Okay, so using periodic table we can find the valency of hydrogen. It is group 1, valency 1. Sulfur, oxygen, sulfur, selenium, tellurium. These are group 6 elements. So here valency of hydrogen 1 and valency of oxygen 2. I told you, using periodic table you can find the valency. So using valency and the symbols of the elements you can make its formula. Okay, first one, hydrogen sulfide. Okay, hydrogen sulfide. Sulfur valency 2, valency of hydrogen 1. Then we had to do cross multiplication. Here hydrogen and sulfur. Okay, this is the valency of sulfur. We have to write over here. Okay, for hydrogen, and the valency of sulfur it is 1. So the formula of hydrogen sulfide is H2S. This is the formula of hydrogen sulfide, H2S. Okay, another example, aluminium oxide. Aluminium, boron, aluminium, gallium, these are group 3. So valency of aluminium is 3. And oxygen group 6. Okay, 8 minus 6. So valency 2. So aluminium and oxygen, symbols of aluminium and oxygen given here, and valency of aluminium 3 and oxygen 2. So we have to do here cross multiplication. So here it will be Al2O3. The formula of aluminium oxide will be Al2O3. Al2O3. Clear? Okay, next one we have to discuss here equation for chemical reaction. We know there are different type of chemical reaction. How to make chemical equation for chemical reaction? For example, carbon reacted with oxygen form carbon dioxide. Carbon reacted with oxygen form carbon dioxide. What is the chemical equation for this chemical reaction? To make chemical equation, we have different steps. First, we have to write word equation. Then we have to write its symbols. After that, we have to balance number of atoms. Clear? So look here carbon reacted with oxygen form carbon dioxide. First write word equation. Carbon plus oxygen giving carbon dioxide. Carbon plus oxygen carbon dioxide. That is word equation. This is word equation. Okay, but also you must know carbon, it is monoatomic. So we have to write C. Oxygen, it is diatomic. We learned in covalent bond diatomic and monoatomic. Okay, all group 7 elements are diatomic. F2, Br2, Cl2, I2. Okay, also H2, N2, O2. This type of elements commonly be using, and these are diatomic elements. Always they exist in the nature. Two atoms join together. They make covalent bond between two atoms and exist in the nature. That's why they are diatomic. So oxygen we must write here O2 because it is diatomic. Okay, so here carbon reacted with oxygen form carbon dioxide, that is word equation, and here carbon this is the symbol equation, carbon symbol C, oxygen O, and carbon dioxide formula CO2. Okay, here oxygen it is diatomic, so that's why here 2. So this is the chemical equation C plus O2 CO2. Okay, sometime look here in this equation, one carbon, this is the chemical equation, here this is the equal, and here this is arrow mark. In arrow mark right side always product. You have to know in chemical equation right side this part always product and left side always reactant. This part always reactant, and here it will be product. Okay, and the number of atoms in each side, right side and left side, number of atoms must be balanced. That is the third step, balance number of atoms. See here in this equation already atoms are balanced. Sometimes you have to balance number of atoms. Here one carbon, here also one carbon, 2 oxygen, 2 oxygen. In this case atoms are balanced. Sometimes atoms are not balanced. You have to balance number of atoms. Okay, also remember product always right side, reactants always left side. Clear? Okay, here balancing chemical equation or make chemical equation. Another example here, hydrogen reacted with oxygen form water. Another example, hydrogen reacted with oxygen form water. How to make its formula? Look here, to make the formula for this chemical reaction, hydrogen reacted with oxygen form water, I told you there are 3 steps. First word equation, symbol equation, then balance number of atoms. So here word equation, hydrogen plus oxygen giving water. Okay, also you must know here hydrogen it is diatomic. H2. Oxygen also it is diatomic, O2. And the formula of water is H2O. H2O, one oxygen and two hydrogen. We discussed this many times, H2O. Okay, so this is the symbol equation. This is the word equation. Okay, so hydrogen plus oxygen giving water. Next one we have to write its symbol equation. Hydrogen it is H2, oxygen it is O2, water it is H2O. So I told you before, product always right side, reactants always left side. So H2 plus O2 giving H2O. Now look here, the third one, balanced number of atoms. Here number of atoms not balanced. Here 2 hydrogen, here 2 hydrogen, okay, but here 2 oxygen, here 1 oxygen, so it is not balanced. So look here, H2 plus O2 giving 2H2O, H2 plus O2 giving H2O. You want to make it balanced. So here how many oxygen? Here 2 oxygen. So write over here 2, right here 2. You can check with a different number. You have to practice it. Okay, you take different examples and you have to make it practice. Okay, use pencil and use different numbers. Okay, so try more and more, then you will get practice. So here use 2. So here 2H2. If you write here 2, this 2 is common for hydrogen and oxygen. 2H2O mean there is 2H2, also there is 2 oxygen. H2O mean this 2 only for hydrogen, this 2 only for hydrogen, but this 2 is common for hydrogen and oxygen. 2H2O mean there is 2H2, also there is 2 hydrogen. So when you write here 2H2O, you did here 2H2O. So here 2H2 mean 4 hydrogen. So write here 2H2. 2H2, 2H2. Hydrogen balanced. Here O2. And 2H2O mean I told you 2 oxygen. So there is 2 oxygen. Here right side 2 oxygen, left side 2 oxygen. Okay. O2 mean 2 oxygen. It is similar to 2O. O2 mean 2 oxygen atom. 2O mean also 2 oxygen atom. Now it is balanced. 2H2 plus O2 giving 2H2O. So you have to use different numbers and practice it. Then you will find this type of equation. You can make it balanced. Okay, so here 2H2 plus O2 giving 2H2O. Also you remember 2H2O means this 2 is common for hydrogen and oxygen. H2O means this 2 is only for hydrogen, not for oxygen. H2O means 2 hydrogen and 1 oxygen. 2H2O means 4 hydrogen and 2 oxygen. Clear? Okay, so here we are discussing here how to make formula. So here we discuss 3 steps to make formula of chemical equation, chemical reaction. Okay, so there is one more step to make the formula. So here we discuss first we have to write word equation, then we have to write symbol equation, then we have to balance number of atoms in right hand side and left hand side. We have to balance number of atoms in reactant side and product side. There is last step, there is one more step in to make formula of chemical equation. We have to use state symbols, state of the matter. We know there are three states of matter: solid state, liquid state, gaseous state. Okay, so solid state we will use this letter S, liquid state and gaseous state. If there is any aqueous solution, we use AQ, sodium chloride in water. It is aqueous solution, so we will use AQ. Okay, so we have to use state symbol also in chemical equation. So we balanced the first one. Carbon reacted with oxygen formed carbon dioxide. Carbon, we know it is solid state. oxygen gaseous state, carbon dioxide gaseous state. So this is the final chemical equation for this chemical reaction, carbon plus oxygen carbon dioxide. So we had to use state symbol. Hydrogen reacted with oxygen water, also we have to use state symbol. Hydrogen gas state, oxygen gaseous state, water it is liquid state. So this is the complete balanced equation for these two chemical reaction. So to balance chemical equation, first we had to use word equation, state symbol, balance number of atoms. Last step, use state symbols. Clear? Okay, so we discussed how to make chemical formula for different chemical reaction. So these are the different steps. First, we have to make word equation, symbol equation, balance number of atoms, add state symbol. We have three different chemical reaction and we have to make chemical equations for this chemical reaction. First one, calcium reacted with chlorine form calcium chloride. So let us see how to make the formula for this chemical reaction. First one, calcium reacted with the chlorine form calcium chloride. So first step, you just write the word equation, calcium plus chlorine calcium chloride. This is the first step, calcium plus chlorine calcium chloride. Okay, second step, we have to use symbol equation. Calcium, it is metal, it is monoatomic, Ca plus Cl2 giving calcium chloride, CaCl2. Okay, we discussed already how to make formula from valency. You can check that part. So you can make the formula for calcium chloride. So calcium plus chlorine calcium chloride. Third step here, balance number of atoms. Check here number of atoms are balanced or no. Here one calcium, here one calcium, two chlorine, two chlorine. So here number of atoms are balanced. Okay, so here we did third step. Here fourth step, here we have to add state symbol. We have to add state symbol. Calcium plus chlorine giving calcium chloride. Here calcium it is metal. So which state it is? It is solid state. Chlorine gaseous state. Calcium reacted with chlorine. It is ionic compound. So which state it is? It is solid state. Calcium chloride. Solid state. So this is the balanced equation for calcium reacted with the chlorine form calcium chloride. Okay, and here next one here we had to do here next one, magnesium reacted with oxygen form magnesium oxide. Magnesium plus oxygen giving magnesium oxide. So here we have different step. First step, write down the word equation for this chemical reaction. Word equation is magnesium plus oxygen giving magnesium oxide. That is word equation. Magnesium plus oxygen giving magnesium oxide. Okay, second step here we have to write symbol equation. Okay, magnesium plus oxygen, it is diatomic. Okay, use this formula from valency. You will get formula here, magnesium oxide, MgO. The valency of magnesium, look here, valency of magnesium it is 2 plus and oxygen it is 2 minus, or you can check, or you can say the valency of magnesium 2, valency of oxygen it is 2. Both valency of magnesium and oxygen is 2. So to make formula for this cross multiplication here, Mg2O2. Mg2O2, both are 2. So you can simplify this with a common number, 2 divided by 2. So it will be Mg1O1. 1, no need to write it. So MgO, Mg1O1 mean MgO. That's why the formula of magnesium oxide is MgO. Clear?
So this is the formula for magnesium oxide, MgO. So use valency, then you will get here Mg2O2. Simplify with a common number. So Mg1O1. So MgO finally. So here this is balanced equation. This is the simple equation Mg plus O2 giving MgO. Third step, balance number of atoms. Look here, you have to balance number of atoms over here. Here number of atoms not balanced. Here 2 oxygen, here 2 oxygen. Here 2 oxygen, here 1 oxygen, not balanced. We have to balance. How can you balance it? In case of H2 plus O2, H2O, I told you to balance here 2 oxygen, you just write over here 2. Now here 2 magnesium. Here number of oxygen balanced. Here 2 oxygen. Here also 2 oxygen. 2 MgO mean 2 magnesium and 2 oxygen. Here 2 oxygen. Here also 2 oxygen. Oxygen balanced. But magnesium not balanced. Here 2 magnesium. Here 1 magnesium. So you must write here 2. So this is the equation. Here number of atoms are balanced. Number 2 Mg plus O2 2 MgO. Clear? Now here you have to add state symbol. This is the equation 2 Mg plus O2 giving 2 MgO. Here we have to add state symbols. We have to add state symbol. Magnesium, which state it is? Metal. Solid state. Oxygen, which state? Gaseous state. Magnesium oxide, metal oxide, it will be solid state. It will be solid state. So this is balanced the equation for magnesium reacted with oxygen form magnesium oxide. We have one more equation here, H2 plus Cl2, hydrogen reacted with chlorine form hydrogen chloride. Balance this equation and write down the final equation. Write down the final equation in comment box. Okay, for this chemical reaction, hydrogen reacted with chlorine giving hydrogen chloride. Write down the balanced equation with the state symbol. Write it in comment box. Okay. So these are the things we have to discuss in this video. Rest of the things we will check next video. So watch next video. Okay. Thank you.